we will use Laplace transform to solve this system of equation. So first we transform the equation in the Laplace transform. So the first equation, if we apply the Laplace transform, we should have x of s minus x of 0 minus x of s minus y of s. Transform of 1 is 1 over s. And then transform of the second equation. Negative x of s plus for derivative of y we have this and then minus y. Transform of 0 will be 0 because the integral of 0 is 0. Alright. X of s, x of 0 is 0, so that is 0. Y of 0 is negative 3/2. So we write this equation. I factor out x of s. We should have s minus 1, x of s minus y of s equal to 1 over s. The other equation, we have negative x of s, and we factor out y of s, we have plus s minus 1 y of s. Of course, the negative 3/2, actually that's the positive 3/2. Move to the other side, we have negative 3/2. That's two equations. Right, either we eliminate x and solve for y, or eliminate y and solve for x. I will eliminate x here because all we need to do is multiply s minus 1 at the bottom equation. The top equation will stay the same. So multiply s minus 1, we have minus s minus 1 x of s plus s minus 1 square y of s equal to negative 3/2 s minus 1. So I just put s minus 1 on the top. We add side by side here. X of s will cancel out, so we just have negative y of s plus s minus 1 square. I can just say s square minus 2s plus 1 y of s. And then we have 1 over s minus 3s minus 3 over 2. Right. The left hand side, when we combine, we have y of s, and we just have s squared minus 2s. The plus 1 here, we cancel with this minus 1, so we don't have anything else. So that's pretty much it. And then we just say 1 over s minus 3s minus 3 over 2. Right, and then we just divide by s squared minus 2s on both sides. So we have y of s equal to 1 over s squared s minus 2, sorry, s times s squared minus 2s. S squared minus 2s times s. Actually, I factor out s squared, so we will have this. And then minus 3 s minus 3 over s squared minus 2s. We can write as minus 3s for 3 over 2. And then we factor out an s, we have s, and then s minus 2. Right. So we solve for y of s. The common denominator, notice that instead of take the 2 here in terms of the common denominator, I'm going to ignore that and keep that 2 on the top. So the common denominator is just s squared and s minus 2. Ignore that, and we bring that 2 on the top. Cannot ignore it. Right. By that I mean on the top we will have minus 3s over 3 over 2. So that 2 we bring on the top like that. And we're missing a power, so we multiply s there. So after we simplify, we should have 1 minus 3 over 2 s squared plus 3 half s squared s minus 2 at the bottom. All right. What next is just do the partial fraction and then solve for it. I will pause the video here and then do the partial fraction, so we will save time. And we continue. This fraction will do the partial fraction decomposition. For s squared here, we're going to have s and s squared, and for s minus 2 we have c over s minus 2. Multiply both sides by the common denominator. We should have this. Combine like terms and all of that. This is what we have. And then we just match in the coefficient. Negative 3 half s squared. Match that with a plus c s squared. And the equation is a plus c equal to negative 3 half. And then the negative 2a plus b here. We can match with 3 half. So we have negative 2a plus b equal to 3 half. And the negative 2b is equal to c. 2b equal to 1, I mean. 1 here and negative 2b there. Alright, next we use the calculator to solve for it. Earlier I used the new form of calculator. Now I've used the old form. Before that, let's just put this in the matrix form, the romantic matrix. 1 for A, 0 for B, 1 for C, negative 3 half. Negative 2 for A, 1 for B, 0 for C, and then 3 half. Negative 2B, no A, no C, and 1. So I'm going to put that in the matrix. I'm using the old form of the matrix, so I have to put the matrix under edit so we can enter the values. 3 rows, 4 columns. I use enter here. 1, 0, 1, negative 3 half, negative 2, 1, 0, 3 half, 0, negative 2, 0, 1. Right. So when we hit second matrix, edit to input the matrix names to recall it, and right, so that's what we have. Now second matrix again, go to reduce row echelon form and do that to matrix A. This is what we have. Let's convert that to fraction. So we have -1, -1/2, and -1/2. On the left hand side, just identity matrix. -1, -1/2, -1/2. So that is A. A is 1, A is -1, B is -1/2, and C is -1/2. Right. With that, we have y of s. So y of s equal to -1 over s plus -1/2 over s squared plus -1/2 over s minus 2. And we continue this on the next page. Let's rewrite that. Y of s -1 over s. I will write in this form: -1 over s minus 1/2 1 over s squared minus 1/2 1 over s minus 2. And then when we apply the inverse Laplace transform, that should be easy. Y of t, the transform of 1 over s is t. I'm sorry, it's 1. The next one is t. It's 1. And then 1 over s squared, that is t. And the next one is e to the 2t. So we have y of t is that much. Next, we will solve for x. To solve for x, we'll go back to the original problem. And we look for the equation that only have x in it. This will be easier because that equation have the x prime and x. That more complicated. We have to use another differential equation for it. So I use the second equation and use substitution again for this one. -x plus y prime minus y equal to 0. And we solve for x. So x will be equal to y prime minus y. Just move x to the right hand side. And then we have derivative of y. Derivative of that is -1/2 minus e to the 2t. Derivative is 2e to the 2t. So that's just minus e to the 2t. So that is the derivative minus the original function. And then just combine like terms. So we have y x of t will be equal to like terms -1/2 -1 with an extra negative here. So it will be 1 minus 1/2. So that's 1/2. Right. Next, we have just minus 1/2 t, that term by itself, minus a negative, turn into 1/2 t. And then e to the negative 2t, we have two terms, one here and negative 1/2 there. And again, we still have the minus. So that will be negative 1 minus negative 1/2. So negative 1 plus 1/2 is minus 1/2. And that's what we have for x. Let's go back and see on the problem. So originally, we transformed the problem into a function of s, and here we eliminate x and we solve for y. To solve for y, we do the partial fraction. After we have y of s, we transform it back into a function of t, and then we use substitution to solve for x. And this is what we have for s, x of t. And that's what we have for our problem.